So this question is something that you might not be super familiar with, but your trick for this is if you come across something that looks confusing and you're not sure, skip it and come back to it. There's no point in the exam wasting all your time on stuff that you don't know and losing easy marks because you've been investing your time there. If you have extra time at the end, come back, have another crack at it, but try and do all of the things that you're really familiar with first. Okay, so our first trick for this is we want to integrate this by considering the derivative of that. So let's take the derivative of it and just see what happens. Okay, so if I derive this, I'm going to get the derivative of this is 2x divided by the original that was there, x plus 4, and that's the derivative of it. So you can see here that this is the same as this. The only difference is that that numerator was multiplied by 2. So that must mean that if you are going to be integrating this, your new integral form is going to be, when I integrate this between 2, 0, for 4x all over x squared plus 4, that is the same as doing 2 times ln x squared plus 4, and we have 2 and 0. So now I've got it into this form, I can substitute in and solve. So 2 times ln, 2 squared is 4, plus 4 will make 8. And we're subtracting 2 ln. This here will be 0 squared is still 0 plus 4, so 2 ln 4. Now, the biggest trick that you guys always forget is these numbers at the front, before you can do anything with them, you have to take them back over here and square these. So now they're gone for the front and they're back up the top. When I've got two log functions subtracting, that means they're dividing. It's the opposite of our index laws. So 8 squared is 64, 4 squared is 16. That's going to give me ln 4, and that'll be my final answer. If you didn't have this sum memorized, you could just keep counting. 16 plus 16 makes 32, plus another 16 makes 48, plus another 16 makes 64, therefore there's 4 of them.